ELN here, and we go to the third in the first session. And this is from Katharina from der Eidgenössische Hochschule, Technische Hochschule Zürich. Katharina, yes, your screen is visible, and
okay. Can you hear me?
Yes, we can hear you, and
okay.
Take your 20 or 25 minutes, and
Okay,
please go ahead.
Okay, thank you very much. Thanks for the invitation to present openBIS here today. I am Caterina Barillari, and I work in the scientific IT services of the ETH Zurich. We are a section of the IT services, the main IT services of the ETH Zurich. We are quite a large section. We are more than 40 people. And essentially, we support researchers in different ways by providing some infrastructure for high-performance computing, for example, support for working with confidential data, with data analysis. And one of the things we do is also provide services in research data management. We develop our own platform for this, which is openBIS, that I will tell you about today. And we also offer services inside ETH based on openBIS, and my role is to be essentially responsible for these services. We offer them inside ETH, but also in Switzerland. And just a disclaimer, I am not a material scientist, so I am a chemist by background, not a material scientist. So the field, I have been working in the last couple of years quite a lot with material scientists, so I'm starting to learn a little bit about the field, but it's not my, my background, as I said. So let's come to openBIS. openBIS has been around for quite some time. It's been developed at ETH since 2007, and it's an open source software, so it's free for anyone to download it and use it. It has essentially three main components to it. One is the inventory management part, which you can use to store your samples, your materials, your reagents, the equipment, the standard operating procedures, if you have any in the lab. Then the second component is the electronic laboratory notebook that you can use to document your experiments and also the analysis of your data. And finally, the data management part. So you can store data connected to the experimental descriptions, and you don't have anymore a mess of data lying around unconnected from the description, which is often still a very common situation. Still, in many labs, at least here at ETH, we are observing the shift now. But until now, it was very common to use paper notebooks and have the data stored on some servers or on some NAS storage, maybe provided by ETH. So this is the setup, how openBIS is usually set up. So openBIS is a client-server application. It is usually installed on a server, so we use VMware at ETH, but this is not so relevant. What is important to know is that the users access openBIS essentially either via a web browser or via API. So we have several APIs, Python, Java, JavaScript, so the users have different ways to interact with the software, but they don't need to install anything on their locally on their machine. So if we look at the different components of openBIS, I said one part is the inventory management part of openBIS. So you can see here a few screenshots of how you can organize, for example, lab equipments in openBIS. So you have an inventory where you can create folders and you can have collection of different things. In this case, we have collection of mixers, for example, and then you can have also collections of different lab samples and materials. In this case, we have collections of chemical AD mixtures. And you can also have collections of protocols. So the protocols would be the lab procedures for the different types of measurements that are done in the lab. And you can control access to the system, so you can give there are different roles that are available for the users in openBIS, and you can give access to some folders, let's say, to some people and not to others. And it is possible also to track the position of samples in storages. So for some labs, especially in biology, for example, this is very important to track the position of some samples in the fridges and freezers. And we also have the possibility to track samples using barcodes. So you can basically attach a barcode to your sample in openBIS, and when you scan the barcode, then the sample pops up in openBIS. So this is a very useful functionality that we see it's becoming more and more used by our users. Coming to the lab notebook functionality of openBIS, by default, every person has their own folder in the lab notebook part of openBIS. This is the default. It can also be organized in different ways, like project, we having project folders instead of personal folders, for example. And here also you can control access, so you can only the owner of the folder can have access to it, or it can be shared with everyone in the lab, for example, or also other collaborators. This depends on the lab and on the users in the lab. And then we have here a page with the experimental description. And here you see a little table where you can basically establish connection to other entities that you have registered in openBIS. And then you see these also represented as a graph. So you see the connections, like in this case, you have, this is a biology, an experiment from biology, and you see in here which samples have been used in this experiment, which protocols have been followed. If you have equipment, you can also link it to a particular equipment that has been used, like it was shown in the lab notebook that was presented before. You can do something similar also in openBIS. You have an audit trail in the system, so basically everything that is created in openBIS is registered under the user who registered the entry. Everything is time-stamped, and every modification then is logged into the system and in the database, and it's visible in entity history tables. So you see for every modification who did the modification, what was modified, and when it was modified. And also when you do deletion, everything is tracked in the database. So when things are deleted, we keep the history of what has been deleted, who deleted it, and we see what has been deleted. If we come to the data ingestion part in openBIS, so in openBIS you can ingest data essentially in 3 ways according to the size of the data primarily. So if you have data that is small, so a few gigabytes, I would say, then you can do this via the web interface. You have an upload button, so you click in there and then you can upload data. You can also do this via one of the APIs, for example, via Python. So again, this is fine if the data are not too large. If you have larger data sets, so going in the hundreds of gigabytes, then you would use what we call a Dropbox mechanism, which has nothing to do with the Dropbox commercial program. Essentially, this is a folder where data are stored. Either they can be automatically moved from an instrument to this folder, or it can also be a manual process. The users put the data in this folder, and then from there is a script that controls the ingestion into openBIS essentially. And then the data will end up in openBIS attached to a given experiment or a sample, depending on what makes most sense. We provide a connection. Jupyter has already been mentioned in the previous 2 talks. We also provide a connection to Jupyter notebooks in openBIS. We actually do provide a Jupyter Hub server that comes with as a Docker installation, and it can be connected to an openBIS server. So what happens if you use this Jupyter Hub server is that you will be able to launch Jupyter notebooks from the openBIS interface. So you have this drop down, you can launch a new notebook, and then you open your Jupyter notebook, you can run your analysis in there, and then finally you can save the notebook back to openBIS. So the idea is to have everything in one place. The data that you generated at the very beginning, the raw data, you can process the data, and the analysis of the results will also be there in openBIS together with the code that you have used to analyze the data. There is also a Jupyter Lab openBIS extension that allows you to use a local Jupyter installation so without necessarily having to use our server. If you have your own local Jupyter installation and prefer to use that one, you can install these and then you get these free buttons. I don't know if you can see them in your notebook that allow you to connect to an openBIS instance, download data and upload data back to openBIS. So this is essentially what this extension does. One important part also is the integration with data repositories. So in openBIS, we provide integration with Zenodo, which is one of the generic data repositories that is acknowledged as a fair data repository. So the idea is that if you have all your data in openBIS, because this is the tool that you use in your daily work, and then at some point you want to share some of this data because you are either making a publication or you want to share a particular data set with the scientific community, you can essentially from the openBIS interface select what you want to export, and then you will need to provide a title for the export, and then you click the button to export to Zenodo. And what happens is that you will be redirected to Zenodo, where you have to finish the submission. And in the background, what openBIS does, it generates a zip file from what you have selected in here, and this is transferred to Zenodo. So then in Zenodo, you will have this, I don't know if you can see it, this is this content.zip file that is created by openBIS, and then in Zenodo, you have to complete your submission. And we also have an integration with the ETH data repository, but of course, this is only relevant for ETH users. Excuse me. So I just want to mention briefly a project that we currently have funded by EGI-ACE, so the European, in the context of Horizon 2020, essentially. So this is a project thanks to which we are able to provide support to the academic community in Europe for using openBIS. So the project started last year in January 2021, and it will run until the middle of next year. So we have only a few months left. But basically, thanks to this project, we have been able to collaborate with a few institutes, primarily in Germany. So you see them listed here. And we have helped them setting up their own openBIS instances in their institutes. We provided support also, some training and support for the data modeling and getting started with openBIS and some trainings and so on. This is the team behind openBIS, a few developers, system operators for running the services at ETH and for the Swiss academic community, as I said, and then the data management team. Here you have some information about where to find us. So this is the openBIS website, where you have also some the documentation and some video tutorials. This is the website of SIS. We are now on Mastodon, and this is where you can reach us. And now I would like to move on to the demo part of this session. So this is essentially the use case that we have been provided, which was to essentially have two batches of samples that are characterized in four different ways. And the samples in openBIS would go to the inventory, and the four measurements essentially would go to the openBIS lab notebook. So this is how the structure actually looks like in openBIS. And now I will move to my browser, and I will show you how this looks like. Also here, there are several ways of implementing things. I have to say I've gone for the easiest possible. In this case, I didn't do many complex things, but we could do it more complicated and add more metadata. So what I have done here is I have created a folder for the samples, and here you see the two samples. So these are the two batches. I see here the information. If I click on one of the samples, this is what I see. And then because this sample has been used in a few measurements, which I have already registered in my openBIS, I have made the connection. So in these connections in openBIS are called parents and children. So basically this sample has 4 children, which are the 4 different measurements. And I can visualize this. This is what I had in my slides as the hierarchy graph. So I see that this sample is connected to 4 measurements, to the tensile test, hardness measurement, power analysis, and SEM analysis. So to register new sample, it's quite easy. I can I can just click on the plus new sample, and this is also the mask, or however we want to call it, the template that I created based on the information that was provided. So I have entered this metadata. Of course, this is you see that this is I created it based on the information I got. This can be customized, but you need to be an admin. Not every user can create these templates. An admin can do it, and this can be done either via user interface or via API. Then if we go to the lab notebook part, and another way what I wanted to show is that also you can create samples in this way. You can also do batch uploads of samples. So you need to use a template provided by openBIS, which you can download from here. And then you can also upload a lot of samples in one go. So you don't have to register samples one by one. If you go to the lab notebook, so I said before in my slides that the default organization is that every person has their own lab notebook. We can also organize this by project, and this is actually what I have done here. I created a folder with the name of the project, and then inside this folder I have in openBIS terms, this is called space. And then inside here, what I have created is characterization of manufacture samples. So this is another folder. And then here I have created the 4 different types of measurements. And for every measurement, then I have basically, I have created a measurement for each batch. So in this case, we have this hardness measurement. I have done it for batch 1 and for batch 6 of the two samples. And then if I click on one of these, I see some metadata here, and then I see the connection to the sample. So in this case, again, I can go to the hierarchy graph, and I see now that this measurement is connected only to this sample. And then if I go back, I see that here I have attached the data, which are the Excel spreadsheet. So in this case, this is what I have done. I have attached the data sets as the Excel files as Excel spreadsheets. If I don't know if it would make more sense to have the information in those contained in those files as metadata here, and then have all the values filled in. This is also a possibility. For the power analysis, what I have done is also here. I have, for example, in this case, I have again limited information, some metadata here. In that case, we had some information in an Excel spreadsheet. So I have created a little table in my notebook where I have copied what was in the Excel spreadsheet, and this is how it looks like. And then here we have the images. So, and then if you see, if I go on the images, I can see that I can have a representation of the images, and the same is for batch 6. For the SEM analysis, same. I have essentially, I've put the minimal metadata here, and then I have attached all the data files in here. I could have also extracted all the information that is in these text files and have it as metadata in the forms. So this is also a possibility. I didn't do it in this case. As I said, I went for the easiest possible way of configuring this, but more complex things are possible. And finally, we have the tensile tests. So we have here again I take the batch 1. So here in this case also, I copied and pasted as a table what was in the Excel spreadsheet that was provided. So you have the information here, but this could also be as metadata in the form, and then we have the image, and again we had some measurements in the Excel spreadsheet that were provided. So I created this spreadsheet also in openBIS, and we have the information in here. And I mentioned before the history. I just wanted to show you where it is here. So we have the history. You can see here I played around a bit, so I changed quite a lot of things here. And you can see here all the modification. I was logged in as admin, so this is what you see here. And then you see when I made the modifications and what was changed essentially. And one thing that I also mentioned before was this connection to the Jupyter notebooks. And here you can launch essentially Jupyter notebooks. So in this case, we have a Jupyter Hub server connected to this openBIS instance. So I can launch a Jupyter notebook either from here or directly also from one of the measurements. So I can launch a new Jupyter notebook. I can say this will detect that there are two data sets. I can select the one I want to analyze. And then I would say, and this opens a notebook that you see there are some cells that are already predefined, where basically in these cells you have a connection to openBIS, and then you get the data from openBIS. And you have here a cell for writing your code. This is by default. We have Python 3, but we also have support different kernels, so R and Python, for example, and Bash and Octave, and and then you can save your results back to openBIS here. And this is what I have done before already. So I have the notebook saved in openBIS connected to my original data. So this is it. I think I have used up all my time. So I hope that this was a little bit of an overview of the different possibilities of what you can do with openBIS. If there are any questions, I'm happy to answer.
Exactly. Are there questions? Nicola, please go ahead.
Yes, Katerina, I have a question about the audit trail that you show. So you record all the change and everything, great.
Yeah.
How can you guarantee that this audit trail cannot be modified by the admins, like the sysadmins?
So this you have to be you need to go to the database and modify directly the database of openBIS.
Yeah.
This I don't know if we have actually if we have a good way to prevent this, that someone cannot modify the database. This is I don't know. At the moment, we don't have a good way for that actually.
Because for me, the only way to prevent that is to do the external timestamping with a timestamping authority. Because let's say I'm a bad researcher, I'm friend with a sysadmin, and I tell him, hey, can you delete this one? And then, you know, like you lose a bit this trust that you can have into the audit trail, because at some point someone can modify it and you will know nothing about it.
This is correct. This would be this would fall under a misconduct, right? If you are discovered
for sure. And this is the whole point
yes.
of having an audit trail, is that if there is a misconduct enquête, like investigation, you need to be able to say, yeah, it was like that at that time, and nobody can tell otherwise.
Yeah. Okay, I will take this point. Thank you.
And I also have another question. Do you plan to have an export in the ELN file format? I know we had a discussion with someone from openBIS a few weeks ago.
Yes, I know you've been talking to my colleague Henry, I believe, on this. Yes, we need to look into this. I think that this is a very interesting idea also for us. So we will look into this. Yeah.
Thank you.
Okay. There's another question in the chat from Dr. Matthias Grönewald. I've seen as menu item export metadata. What is the output?
The output is actually a zip file. So now I cannot show you here because basically what happens if you do that. So here, for example, if you do export metadata or export metadata and data, what happens is that you get a message that's saying that the export will be ready in a bit, and you get essentially an email with a link to download a zip file. And this zip file contains the information that you see here organized in the same folders you see here. And for every level, so where you have some the metadata, for example, here you have it in 4 different formats, which are a text file, a JSON file, an HTML file, and a Word document. So this is what is currently provided.
We have another question in the chat. Is it possible to set up openBIS on Docker?
There is a Docker installation, yes, of openBIS available.
So, okay, if the questions run out to Katerina, then I think